Good morning. Uh, Welcome to the next part of my lecture video series on Chapter 4, um, Local Linux Authentication. Um, I started off, I'm going to get to the lecture in just a minute, but I wanted to demonstrate a little something first. I created these accounts, the other day when I was working on SE Linux. I created a JRandom account and a JRH account. Now, what you see towards the top of this terminal session is the end of my Etsy password file. You'll notice that the user account AMP has something at the end, home/amp, then :bin/bash. That is a path to a shell. And JRH for JRandom Hacker has the same thing, but JRandom does not, because JRandom is a random user, not a random hacker. And he doesn't have. Now, what would happen here is that this JRandom account without some kind of information would never be able to log in. So what I'm doing is actually using the change shell command, as I want to generate some events to show you here in just a minute once we start talking about the accounts command and what it can do. But I needed something to talk about, really. And I might actually generate a few others just for giggles. Anywho, if the final section of this Etsy password line for any given account ends with no path to a path or a path to a non-existent like path, like say for example, look at the color daemon, or up here the AVAHI, the sane daemon, etc. Debian's GNOME desktop manager. All of these things have something like /bin/false, which is a shell that doesn't exist. So it would be literally impossible to log into an account like that, because the system will very dutifully go looking for a command in /bin called false. And so if you see say a no login option, which I think we may discuss here in a minute, that will do the same thing. So what I'm doing is the change shell command. Of course, I'm doing it as sudo, because change shell is one of those commands that belongs very definitely to root. You could also actually do this for yourself. Say, for example, you developed an affinity for the Korn shell or the Turbo C shell or something like that. If you wanted to change your own shell from the default, which is bash, or say for example you are a Mac user, a Mac OS X user, and you've gotten really used to Ash, and you've transitioned to using Linux some of the time, but you still want to do everything you know how to do with Ash rather than learning Bash. That's valid too. So you could install the Ash shell on this system and then point yourself at it. So what I'm going to do here is make this one bin/bash. And it's going to think for a minute. Okay, there. So now, before, I could not have attempted to log in as JRandom. It just would not have worked. Say, for example, if I had done, let's see, that may be the wrong password. Okay. Anyway, so um, just a second, and I will start talking about the lecture. Thanks. So when we left off, I was talking about user authentication and logging. Everything goes into /var/log, practically speaking. You may have programs which log their own stuff in their own places, but that's kind of a POSIX standard violation. One of the things we learned about at the very beginning of this was the file hierarchy system, and the POSIX standard. That's why you can write a program for one variety of Linux or Unix And as long as the target varieties of Linux and Unix are relatively POSIX compliant, then you don't have to worry about that aspect of porting that code to a new platform. You can take the file paths that you'll need for granted and then move on from there to the nitty-gritty of the problem you're trying to solve. So we talked about the last B and last log, the last command, a dmesg, and of course, if you're looking for something specific in dmesg, you can of course use grep. Say, for example, you're trying to figure out why your Linux box won't play DVDs or won't even read DVD. Not so much just not playing a movie, but not even reading a DVD of any kind, whether it's a movie or a game or whatnot. It can say, for example, it can handle CDs just fine, but not DVDs. What you could do is figure out what the name of that device is and go look for it in dmesg. What is the kernel doing when you try to put a new CD in and close the tray and it spins up and it stops? What happens there? And then you can use that as the beginning of your troubleshooting process to try to figure out, okay, how can I make this computer play a DVD? So let's talk about limiting login capabilities. I sort of talked a little bit about the next slide on this, disabling login entirely, but you can instead of just disabling a specific user account's login completely, or as I demonstrated in the PAM lab, controlling whether or not a specific user can access a specific service or daemon, say SSH or the cron daemon or the @daemon or whatnot. You can decide literally which consoles you want people to be able to log into. Say, for example, you don't want them to be able to use their Control-Alt function keys to bop over to from TTY2 to TTY3 or 4 or 5. You can actually get into this etc secure TTY file, and then using the hash, using a pound sign, a hash character, comment out all the TTYs you want to close off, so that only the TTYs available, the only TTYs available will be the ones that you want people to use. Say, for example, you want to make sure that users are locked into, shall we say, a graphical form of run level 5, which is the GUI target. If you figure out which of these TTYs your system is going to boot to and place the X Windows session on, then you could comment everything else out so that it can load your GUI session, your desktop, into the appropriate TTY line, and then do nothing else. Because this is truly, Linux, as I've said before, is a truly multi-user system. Multiple users can be logged into the system at the same time using it. And also, as I've demonstrated in class from time to time, the same user can be logged into the same system multiple times on multiple TTY lines. So there are other things you can do here. You can also go into the login file in the etc pamd directory. You'll invoke the PAM access module. There are actually a lot of modules because PAM, of course, stands for Pluggable Authentication Module. So in the lab we used the other day, we used one of PAM's modules to control whether or not anyone could use SSH. You could also use the authentication module, and say you go into your edit the contents of pamd./login or etsysecurity-access.conf, and you could say, for example, disable root access on TTY1 to make sure that someone who couldn't try to bypass your system security by moving over to another terminal line and logging in there directly. In terms of disabling user accounts and logins, every user who exists on the system is in the etc password file. On systems which have dissociated the password itself from the etc password. Now, we call this the password file. And in some older legacy implementations of Linux and Unix, the password was actually in the password file. If you look at a password file now, what you'll see is the username, and the next character is, the next field is an X. And let me see if I can actually show you this. Like this, see? AMP colon X colon 1000, 1000. That's my username and my group number. My user ID and my group ID. I have a user of, that tells me that I have a group of my own name. Anywho, that X is a placeholder for what is actually in etc shadow. So let's do now. Anyone can look at etc password. Only the root user. Let's see. Actually, let me do this ls dash. Oh, sorry, I meant for a long listing. 8. So see, the root user can read etc shadow and write etc shadow. Other members of the root group can read etc shadow but not write to it. Literally no one else can read etc shadow. So let's do sudo cat etc shadow. Now this is going to scroll off the edge of the screen at me. There we go. See, you see all that ugly gibberish? That ugly gibberish these are the hashes for the accounts. If you see a star, that means there really is no password. With mine, you see a big long ugly string, and you notice also that my big long ugly hash string is different from JRandom's, which is different again from from the JRH account. That tells me that these three accounts have 3 separate passwords. I kind of thought I didn't do that, but oh well. I am sudo. I do have sudo privilege. I can change this if I want to. Anyway, some systems have all of this in a single file. Most modern systems have a password file and a shadow file. Only root can read shadow. Now, that's important. The reason that only root can read shadow is in part that what if you can exfiltrate a copy of somebody else's shadow file? Then all you need to do is build yourself a rainbow table and then throw your rainbow table at your shadow file, and as the saying goes, see what sticks. By pre-computing millions, if not tens of millions of hashes of common passwords, you can essentially do a brute force attack without any login attempts leaving any trace. Now, say, for example, if I were to take this password out of the shadow file, or if for some reason you had to unshadow the file, there's a command, I think, which will take the contents of the shadow file and remerge it with password. Now, if you do that, the merged password file needs to have the same permission settings as what used to be the shadow file, because again, you don't want someone to exfiltrate that data and then proceed to brute force it with a rainbow table. You can also do things with you can do a lot with the password command. The most obvious thing to do, of course, is to change a password. The other things you can do, you can lock an account, you can unlock an account. You can see if the user account status is locked or unlocked. You can even use usermod to do kind of the same things. And I'll be back. I'm about out of time on this video, so we'll move on next to user activity monitoring with the account command. Thanks.